Hello, this is Embedded. I am Alicia White, here with Christopher White. When I say graphics, do you assume I mean a big game computer? What about in embedded systems? This week we'll be talking to Gabriel Jacobo about embedded graphics and MQTT home automation.
Hi, Gabriel. Thanks for joining us.
Hi, Chris and Alicia. How's it going?
Good. I know you have worked at some company we're not going to talk about with my husband, but how about you give us an introduction of yourself as though you were meeting us for the first time at a technical conference?
All right. My name is Gabriel, or Gabriel in Spanish. I'm an electronics engineer, and I typically work remotely with US companies, usually in software or firmware development. And lately I've been working firmware graphics and systems engineering.
I thought he would go on for longer.
And I have 3 kids, and I like gardening.
Well, let's do lightning round, and we will dig into more because despite your short introduction, you have done many interesting things. So lightning round, we ask you short questions. We want short answers. And if we're behaving ourselves, we won't ask you why and how and all of that. Christopher, you ready?
Yeah.
Gabriel?
Sure. Let's go.
Star Wars or Star Trek?
Star Wars. What's the start?
What's your favorite X window manager?
Wayland.
GNOME or KDE?
What's GNOME? KDE. I've been using KDE constantly for the last 10 years. I wouldn't exchange it for anything.
Dinosaur movies or shark movies?
Dinosaur.
Is the Amazon a river, a bookstore, or a tribe of fierce women?
For me, it's a bookstore or online shopping destination.
See, I had a sales platform in that question, but you just
long. I was tightening.
it.
I was tightening.
And I'm a little uncertain about your answer because when I asked you about Amazon earlier in the week, you said it was a river.
Yeah, because Amazon doesn't really have any presence in South America. But anytime I go to the US, Amazon is probably the first site I visit.
What color should a llama be?
Say again?
What color should a llama be?
Oh, what color? So the thing is, llama means flame in Spanish. So that's why we were talking about it being of different colors. Blue is the color of a good flame. So I'll go with that.
Do you like to complete one project or start a dozen?
I'd like to complete one project. What I actually do is start a dozen.
All right, let's go and let's dive into things. Graphics. When you say graphics, and I know you've done a lot of different work in graphics, what does that word really mean when you're talking about embedded systems and graphics?
So graphics means different things to different people. For end users, it means probably what they see on screen. For designers, it means the way they communicate with users. And for us firmware engineers, it's the whole pipeline that goes from assets to some processing, the frame buffer, and eventually pixels on the display.
It's a little odd because I would never say I've worked in graphics, but I have put bitmaps into Flash and then gotten them out and put them on the screen.
Yeah.
Should I be saying, oh yeah, graphics is on my resume?
So when you did that, did you constantly write to the screen? Did you worry about doing the minimal amount of work possible to preserve battery, for example? All of that is, I think, graphics work in a way.
Yeah, I did all that. And I actually drew a graph too. So it wasn't just splatting things on the screen. I had to worry about pixels.
Yeah, I think you can put that on your resume.
Okay. Graphics
yeah,
expert.
Graphics is usually expensive for batteries, so for embedded work, anything that saves you on drawing time, on redrawing things that you don't need to draw, even if you're just like moving assets from the flash to the display, that's a fairly complicated process and definitely worth putting in your resume.
Could you go through the process for us?
So the center of the graphics process is what's called the frame buffer, which is a complicated word for an array in memory, a buffer where the pixel information is going to be, and it's going to be sent to the display through some mechanism. The assets typically come from a flash storage, SD card, depending on the resolution. It's the type of storage that you're going to have. There's going to be some sort of DMA transfer from the storage to RAM memory or even directly to the frame buffer. And then there's going to be some processing done either by the CPU in what's called software rendering or by a GPU in what's typically called hardware accelerated rendering. And then that frame buffer is composed into a frame, and that gets sent to the display at a certain time. The timing of sending images from the frame buffer to the display has a little bit of complexity because the display is doing its own thing and the CPU is doing its own thing, and if you don't coordinate that properly, you end up seeing strange artifacts on screen, which you don't want to.
Well, that depends on how much complexity you have in the thing you're displaying. If you're doing something very static, then usually you don't have to worry about that. But if you have a lot of animation or changing data or numbers, then you get into the complexity of, I don't want to update the screen while I'm still updating the data that I want to put on it for the next update.
Yeah, exactly.
And that assumes you have a frame buffer on your LCD and that your micro isn't acting as frame buffer and having to send things every update.
Yeah,
right?
So displays typically work in one of two configurations. The simplest one for the display is basically a mode that emulates what all CRT's display did, which is you have a V-sync signal, an horizontal sync signal, and pixels, and you send stuff to the screen, and that gets reflected immediately into pixel information. And then an evolution of that is displays with graphics RAM on them, where the microcontroller can send information at a given time, and then that gets displayed to pixels after a certain refresh period.
Yes. If your data sheet says you have to use H-sync and V-sync, run away. Yes. Run away very quickly. Well, I mean, you have to often because it's cheaper, but it is a lot simpler in the code to have something that has onboard RAM. But you pay for it in your processor because now your processor is doing all of that.
But everyone knows that firmware is free, so that's why they're typically used to exchange hardware complexity for firmware complexity.
So that's all how you would deal with like a bare metal system. But you worked on this thing, what's it called? SDL, Simple DirectMedia Layer, which of course, I mean, it has the word simple in it, so it should be simple, right?
That's it's anything but. It's simple for the end user. It's quite simple for the end user, actually. It's not simple in its implementation.
Well, what is it? What is it? First, like if somebody hasn't heard of it, what is the general description?
So let's start with the simplest case, right? You have a frame buffer on an RTOS, and you create your rendering engine, right? So you tailor everything for that RTOS. Your whole rendering pipeline is oriented towards having just one frame buffer that you can directly access, and everything works nice. Your input comes from interrupts or whatever. Then imagine that you want to port that with a minimal effort to, I don't know, a desktop simulator on Windows or on Mac. Then all your rendering functions basically stop working because Windows uses its own API for rendering and for window creation and for input, for events, etc. And Mac uses a different scheme. Linux uses a different scheme. Android doesn't even have a main loop that you can use. So what SDL does is abstract all of that into a single API / application philosophy. So instead of having to worry about how you create a window on Windows or Mac on Linux, you call SDL _create window, and everything is magically solved internally. You don't need to worry about how the main loops of the OS work. You don't need to worry about how to read the keyboard or the gamepad or the mouse. Everything comes as events in the same way across all platforms. So it's basically a hardware and OS abstraction layer.
Like Qt? Qt?
To some extent, but Qt is much more. It's more of a total application framework. So it has networking and all kinds of stuff, language extensions. Whereas this is in C. It's more directed toward input and graphics. Do I have that right?
So I don't know how Qt abstracts platforms internally, but you could have, for example, a Qt port that works on top of SDL if you wanted.
Sure.
SDL provides the bare minimum layer to abstract window creation, input, Opengl context creation, and that's it. Qt provides a whole bunch of other stuff on top of that.
Okay, how do these relate to like Opengl and Direct3d?
So after you create a window, if you want to render using GPU, you need something that's called an Opengl context, which is basically a way to reference what you're doing for the hardware to know that you're the one issuing instructions and which texture you own, etc. So the way you do that is different on each platform. Creating an Opengl context is not really part of the Opengl specification, but a part of the window manager / Opengl integration. So SDL abstracts all of this, and it manages the Windows way of doing it, the GL way of doing it, the Mac way of doing it. And you just have to call SDL GL create context or whatever it's called, and you get a context and don't have to worry about any of the internal details. And it also has a neat way to, in Opengl, you need to load the function pointers from the library if you don't want to link statically, and it helps you with that as well. It's not the only library that does this, but it's a nice utility that it provides.
How does all of this... So I know you're an expert in SDL, because I know you've contributed to it. It's an open source project. How does this all relate to embedded systems?
It doesn't. So SDL doesn't really have support for an RTOS, right? So if we equate embedded systems to having an RTOS or not having an RTOS at all, SDL doesn't really apply here. But there are a growing number of small wearables that use Linux. And if you want to, for example, develop an app and not have to download it constantly to the device to try it, you can develop an SDL app. You try it on the desktop. You use the Opengl ES graphics stack. And what you see on the desktop is going to be exactly or very close to what you see on the device. And so that cuts down development time by a lot.
And there are many devices doing Linux embedded.
Yeah.
If I wanted to have something that was doing Linux and was making graphics, I mean, I guess, when I do embedded Linux, I just plug in an HDMI screen and it all just kind of works. But that's not what you're talking about.
Let's say, can we consider the Raspberry Pi to be an embedded platform?
Yes.
Yeah. Okay. So let's say you want to develop for a Raspberry Pi, and you don't want to compile everything on device because it takes forever. So you cross-compile. And then once you cross-compile, you have to download it to the Raspberry Pi, try it, run it, try it with the whatever input you've managed to connect to the Raspberry Pi and see what it looks like. Or what you can do is have what's basically that same app on your desktop, build it, try it there, mess around with the UI as much as you want, and once you're settled with that, you know that SDL is going to abstract most of the differences in hardware because your desktop has a different GPU and it probably has a different resolution, etc. And so you send that, which is basically pretty much the same code, build it on top of SDL and Opengl ES, and that should run on the Raspberry Pi mostly unmodified. So this doesn't mean that you cannot develop on the Raspberry Pi directly or that you shouldn't. This saves time, especially if you're doing a complex project.
It's also nice to be able to give a simulator to your designers and say, well, this is what it's going to look like on the thing. And then you don't care if the designers are using Mac or Windows or Linux, and you still get a reasonable facsimile of what their version of graphics is going to look like on the embedded version of graphics on the device.
Yes, and if, for example, tomorrow a competitor to the Raspberry Pi shows up and the software stack that they provide doesn't have a window manager, but it has direct hardware access, for example, most of the Vivanti GPUs have that. So SDL supports Vivanti's GPUs directly, and it can create windows on the hardware directly without having to go through a window manager. So your code runs on that. It's a different GPU, a whole different system, and you don't have to change anything for that to work. And of course, if you're doing things like games, you support multiple platforms out of the box with minimal effort.
Yeah, when I looked into SDL, one of the things that people were saying about it was that it's a game engine. I'm like, I don't think that's right. But
so it's not a game engine. It's a platform and OS abstraction layer. You still have to make your own engine on top of that.
But SDL makes it simpler because you can make a game engine that is mostly cross-platform because you don't have to worry about the display systems.
The display and the input and many other things. Yeah, sound as well.
In addition to that, you did a database thing with SDL. Let me see if I've got this right. Community-sourced database of game controller mappings to be used with SDL2 game controller functionality. I don't think all those words go together.
So one of the things that SDL added quite recently, or maybe in the last 4 years, is a way to abstract game controllers. So if you look at different game controllers, the most popular ones are the Xbox and PlayStation ones. And then there's a whole myriad of buttons and things that if you're a game developer, for example, and you want to map all of that variety to something consistent on your game, you're basically facing a titanic task because you need to know what possible things the user may have in their home and that they'll attempt to use on your game and map that somehow to the game. One of the most common solutions is to have some kind of mapping functionality in the game where it says, okay, press the button to jump, and you press something, and then that gets recorded. The database that you're referring to is a way to formalize all that. So SDL supports mapping of many controllers to an Xbox controller format. And people around the world have been contributing those mappings that they do with the controllers that they get their hands on. And we aggregate all of that into this database. So when anyone wants to ship a game and support a whole bunch of controllers, besides the ones that SDL supports out of the box, which is a fairly minimal amount, they load up this database and they can support, I don't know, the last time I checked, it was like 300 controllers.
Mentally, I have this pictured as though I was using Code Composer and switched out the key bindings to match my Visual Studio code. Is that a good mental model, or is that just totally...
Yes,
okay,
that's exactly what it is, yes.
The mental model of somebody who doesn't play enough games.
That's true.
Or plays with keyboard and mouse.
No, I have the VR system. I play with my feet. So this database thing and the SDL things you do, and it's all open source, and how do you get paid?
You don't. It's an investment, basically. So the story is that I started with some friends, tried to make a game. To make a game, of course, the first thing that they tell you is, if you're making a game, don't make your own engine. So what did we do? We started making our own engine.
Of course.
The engine was based on SDL, and SDL had a number of shortcomings that were angering me, so I started contributing there. And one thing led to another, and ended up working on a company in the US that basically found me through my open source contributions. The reason why I did those contributions is to learn, and also to get some recognition, or it's a way to build up your resume when you don't have specific expertise in the area that you want to work in, probably. So yeah, it's there's a lot of paid open source development, but I haven't been involved in that. It's been everything's been voluntary for me.
Cool. I have some listener questions, some of which you've seen because you're in our Slack channel. Let's see. How about...
So the secret is out.
Many people are in our Slack channel. And if you want to be in our Slack channel and you're a listener, all you have to do is contribute $1 or $2 on Patreon, and then you get the link, and then you can say hello. Okay, so Nick the Exploding Lemur, asked if you have any tips for hunting down processors with stable graphics drivers and or easily acquired graphics engine specs and open drivers.
So the state of GPU drivers is it's very bad. The only ones I know of that are open source and quite good actually are the Raspberry Pi one, which is I think a work in progress. And then on desktop you have the Intel ones. Besides that, everything is behind 3 layers of DRM and NDAs, and Chris knows about this. You talk to one vendor, and they talk to the other vendor, and you finally get to the one that sells the GPU IP, and nobody gives you any internal details unless they're probably talking from BP to BP level. It's very complicated.
And of course, they're doing super secret stuff. So I can understand them not sharing. No, it's all the same. Everyone's doing the same stuff.
Yeah.
What about below that? I mean, that's GPU stuff, but in the microcontroller world, there's not a lot of, for hobbyists or people, doing thinking about a Kickstarter project, there's not a lot of devices that help out much with graphics in the kind of the 2D space.
Yeah, I've seen a couple of ST chips that have a 2D accelerator, which is essentially a DMA engine that can do like 2D transfers, where you can specify an area and copy it to another area. And a bit more evolved than that is an engine that can do scaling and maybe rotation in 2D. But that's pretty much it. The other issue with this kind of implementations is that they're very ad hoc. So each manufacturer does their own thing, and there's absolutely no standards. And maybe many of those implementations are not very distributed, so expect plenty of bugs if you're doing that. And it's a huge security risk in a way, because you're moving data around behind the CPU protection mechanisms, so you can easily shoot yourself in the foot if you're not careful.
When you talk about moving data into frame buffers and being able to scale it, some of that has to do with fonts and having a font in Flash and then moving it to the screen, or having a letter in Flash and moving it to the screen because a font is a series of letters. How do you deal with fonts? Do you have a favorite font? Do you prefer to do vectors and take the computing overhead? Do you usually use bitmap fonts? What do you want to do?
So, yeah, vector fonts are ideal. They usually cost you just a little bit above of what you can spend on embedded systems in terms of RAM, mostly, because they hover around 100K, and 100K is probably just outside of your budget in many embedded systems. It's basically a compression mechanism, right? You have the vectors in a file, and when you want to render something, you tessellate these vectors into a bitmap and cache that probably somewhere and use that. So if you are using bitmap fonts, what you're doing is most of the same process but offline. You start from a font and you render the bitmaps and you store only the bitmap on your flash memory. The issue with that is that you cannot really change your text size, and you need to have space to store all of the glyphs that you want to render, which, if you're supporting things like Chinese, for example, is not a trivial amount of space. I think most of the Cortex-M processors can render TrueType fonts correctly if you have the RAM. So if you have above, I'd say, 256K of memory, you should probably give TrueType fonts a go. They're easy to work with.
They were easy to work with. See, I always heard that they were really hard. I've kind of avoided them.
Well, you need a library.
Yeah. You have two open source libraries, FreeType and STB TrueType, which is actually one of those single header libraries that Chris likes so much. So you just use that, and it gives you a bitmap of whatever you want.
Okay, good question from Ben, which was initially phrased, why do the displays at the gas station take 5 years to update for every key press? And then was changed to, what are some common mistakes made during embedded graphics programming?
How much time do you have?
All of it.
About 35, 40 more minutes.
Oh, we have MQTT too.
Oh, right.
So,
okay. Less time.
I think the thing that people don't understand, the most common misunderstanding about graphics is that graphics is a bandwidth bound operation, right? You do have some CPU processing and GPU processing, but the first limit that you're going to hit is going to be the bandwidth limit, because it's mostly about transferring information. So in the case of very slow displays in gas stations or ATMs or whatever, what usually happens is that they choose a processor for price reasons or business reasons or whatever, and then they make a totally separate decision about the resolution based on what displays they can get or what resolution, what visual impact they want to have on the user. And then those things are completely separate, and they usually don't match up. And then that's why you end up with those ugly low frame rates that you typically see.
And this is one of the reasons that we do, when we talk about DMA, when we talk about graphics, because it is all about moving things from here to there as fast as possible and still being able to do other stuff.
Yep.
Are there other common mistakes?
The other common mistake, which is related to probably one of the other questions that I saw on the Slack channel, is across products. The resolution is evaluated as a new thing all the time. So you change products and you change completely the resolution because, again, business reasons or availability or whatever. And then you start, on your second product, you start maintaining two sets of assets which don't really mesh with each other, And on the third iteration, you start handling 3 types of aspect ratios, and it all gets complicated. So if I could make a choice across an entire set of products, I'd say stick to the same resolution, or at least stick to the same aspect ratio on your screen.
That's a hard problem even when you're not doing a small embedded system. It's even if you're doing something with Linux, or Apple's had this problem, right? Oh, we came out with a new phone and now all the developers have to go and regenerate everything. And there's no good way to make this automatable because things don't look good when they're scaled or when they're automatically laid out. So yeah, it's a big problem every time.
When you look at movies, I mean, you have different scaling on whether you're watching it on TV with the black bars or whether you're in the movie theater, or whether you're watching an old movie or a new movie. The aspect ratio and resolution, that's just a never-ending problem.
Yep.
And trying to decouple it in your code is a great idea. But as Chris said, it looks different. So you can't just say, oh, well, we're going to pound def that out. It doesn't work like that. Yeah.
So there's a few techniques that came mostly from the web development world. Because web pages are subject to a bunch of resolutions, and they need to look from this. Basically, what's the same set of assets and code? They need to look the same or roughly the same. So there are techniques to minimize that, but they cost in terms of firmware development and CPU processing power. So they're not always feasible on embedded systems.
Well, let's go on and talk about MQTT, because there were some questions about that, and I heard you have been doing some home automation.
Yes, though I must warn you that MQTT is so great that I'm willfully ignorant of all its internal implementation details. I enjoy it as an end user, mostly.
Well, what is it?
It's a communications protocol, typically associated to IoT devices. It runs on TCP/IP, and it follows publication subscription methodology principles.
Okay, so you've already said TCP/IP, and I'm like, oh, well, I'll just take out all my micros, because that's heavyweight to start with, and then this is on top of it?
It's the Internet of Things. If you don't have TCP/IP, you're just a thing.
I'm okay with that.
There's a variant that I'm not really familiar with that doesn't run on top of TCP/IP, but I mean we're talking something that can do at least Wi-Fi or Ethernet and have a TCP/IP stack.
Okay, so it's on top of TCP/IP. So guaranteed transmissions as long as you have the path between them. And publish, subscribe, so your widget, your IoT thing, probably publishes the data, and then some server-like thing subscribes. How does it work? So
there's you need to have one broker. I use Mosquito. There's a bunch of them, which is like the hub, the central point of the MQTT network, and then everything else is a client, and each client can subscribe or publish information. The process is you publish something with a topic and a payload, and the other clients can subscribe to a topic, and when you publish to that topic, they get the payload that you transmitted. It's geared towards IoT devices, so the whole my device went offline is baked in. You have messages for availability. So whenever you come online, you say, I'm available, and whenever the broker sees that you've gone offline because you don't respond, it sends automatically a message saying this device is offline. It also retains the broker can retain messages. So, for example, if you want to talk to a thermostat and have a temperature setting, you publish, ADF. I want the setting to be ADF and retain that. So whenever the thermostat comes back online, the broker communicates that information automatically. And the other piece of technology that it has is a QoS setting, a quality of service, which says if you want the message to be transferred once or if you really want to make sure that the message is received by other clients.
Okay, so Mosquito is the broker and it is sort of the hub.
Yes.
What do you run that on? Do you have like a home server or are you running that on like a Raspberry Pi sort of thing?
So at home, I have a Has.io distribution, which is the Home Assistant distro that runs on the Raspberry Pi. It's centered around containers, and on one of the containers, you run Mosquito, and everything talks to that. And Home Assistant talks to that as well, so everything connects through the Raspberry Pi.
And what do you have for the devices?
Oh, devices, it's mostly ESPs, 8266 Node MCU for the doors and lights, that kind of thing.
Did you say Node? Node?
No, yeah, it's called Node MCU, sadly.
Node.js?
No. You don't have to install 10,000 dependencies for it to work. Yeah. It's called Node MCU, and it out of the box, it runs Lua, so nothing makes sense.
Okay, what are you building with this? When I first heard of this, you were going to do like one little thing.
Yeah, I had a greenhouse temperature control. Now I have 2 doors, lights, the home alarm, and the heating system of the house connected there. It's pretty neat because you program everything in Micropython, or if you're doing something a bit more intensive, you use Platform.io, the Arduino Framework, and it's just plug and play mostly. It's a very satisfying way of working. I don't even know how you install the tool chains for this. Everything is click, 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 click here, and everything works magically. It's amazing.
What about power? I mean, if you're alarming doors, if you have door alarms, don't those just run on batteries? The ESPs are okay, but they're not like long-term batteries.
As the ESP for the alarm is connected to the alarm battery, which is like a huge brick that can last a few days. Yeah, that's no issue. And also I've been worrying about battery life for 4 years, so I don't care anymore.
MQTT comes in flavors. Do you have to worry about any of that, or does it all just kind of poof works?
It magically works, yeah. I don't think there's versioning, at least. So since I'm building everything basically from the same source code, everything works. I don't know if I brought in a binary from somewhere else into my home automation, which doesn't seem like the best idea in the world. Probably won't work. I don't know how it manages versioning, to be honest.
You make this sound very easy.
It's surprisingly easy, yeah. On Python, you just create a client and issue MQTT.subscribe to some topic, and you start getting callbacks for that. And that's all you have to do. It's 3 lines.
It's funny as you talk about the architecture of it with the publish and subscribe and the broker, and it sounds very much like robot operating system. Okay, but going on to the next subject in my long list of things to ask Gabriel about. Where are you based?
I'm in Argentina, in a city called Mar del Plata, 400 kilometers south of Buenos Aires, on the coast. And
I have met you in person near San Francisco. How many hours did you have to travel to get to San Francisco?
So there's no direct flights to San Francisco from Argentina, and there's definitely no direct flights to anywhere from my city. So I had to take a bus to Buenos Aires, and then you typically go to LA if you're lucky, and then from there to SF or San Diego. So it's about 22 hours if you're lucky.
So you don't commute regularly?
No, my commute is from my bed to my desktop.
How do you handle that? How is working remotely for you, and how do you make it work and not Distractionville?
I mean, it's a nice deal. It's not easy to get started doing this. It has all the challenges of working at home, focus, and of doing the things, especially working in hardware. Being in Argentina, the hardware needs to be shipped. It needs to go through customs. That's a whole ordeal. And then the companies that you work with need to be remote oriented in a way. They need to be prepared to have remote workers and have the philosophy required to do that. But that's probably not different from the work that you do there, right? Being remote 100 kilometers or 1,000 or 10,000 is the same in terms of human interaction. The things that get more complicated is when you jump across countries and you're doing hardware projects. I started doing software projects, basically web development initially, because it's much easier to work like that against the server on the Amazon cloud, not in Brazil but in Seattle. That if you depend on hardware that maybe breaks and you need to wait a week or two to get a replacement back.
Do you have any advice for people who want to work remotely in general? And then do you have any advice for people who want to work remotely internationally like you're doing?
I think the first thing, if you want to work, for example, from Argentina for US companies, is just get started. Just make an account on Freelance or Elance or Odesk or whatever it's called now, and just get gigs doing PHP or JavaScript work, and it's going to pay very loudly. Just do that for some time to get used to working remotely. You're not going to get the most amazing jobs doing that, but you're going to create a resume and work that you can point to maybe more interesting employers, saying to them basically, I'm responsible, I can manage my own time, and I can get things done. And then after that is the same as for any work. You need to establish relationships with people, and people need to know you and know what you can do. And if you cannot get into an area that you want, then look for open source projects that you can contribute to as a way to prove that you can get the work done.
Are there any other pitfalls that you've come across just in terms of mechanics of things like shipping? I know that sometimes shipping hardware can be a pain because it gets either confiscated or stuck in customs. Are there ways to suggest to the companies you work for to smooth those things over, or is that just kind of the cost of doing business?
Yeah, in Argentina in particular, FedEx is the... Can we advertise companies?
Oh, yeah.
Yeah,
FedEx, please send us a check.
Yeah, exactly. Let give us a couple of free shipments. It's the best way to send things. They typically take a week to get stuff here, and it usually doesn't get bothered by customs if you stay within the courier weight and price limits. And then if you go beyond that, then you start getting issues, right? But that's like a logistics problem that it's not really in your hands to solve or to do anything about. I say that the most difficult thing working remotely, probably for you, is the same, is getting people to acknowledge you and keep you in the loop on things. That's when you're not physically present and talking face-to-face to people, the relationship changes.
Especially when there's a time zone change.
Yeah. So if you can visit in person every now and then, that smooths things a whole bunch too.
And I found that working remotely has helped with some jobs. My lab is pretty good compared to many of the startups I work with. My office is extraordinarily quiet compared to many of the offices I visit. And when I work remotely, we get better at documentation.
Yeah.
Part of that's just because I document things and I like to have them documented because I like to forget things very quickly and the documents help me. But also the documents help them, whether they realize that or not. I realize it when somebody emails me from a client I worked on 2 years ago and says, I thought this would be impossible. And then I read your document and realized I only had to uncomment like one line and it was all good. And that sort of thing is awesome.
Also, you cannot nap if you're working in an office, right? And by this,
that is not true.
But yeah, I mean, yeah.
It's less true than it used to be.
Yeah. So if you're not feeling well, if you feel like you're blocked by a problem, it's easier to just get up and take a walk or whatever, clean your head and come back, concentrate on the problem, really think it through. Especially the open office plans that have become typical in the US are very distracting, and it's, at least for me personally, mostly because I'm not used to them, it cuts my productivity a lot when I'm there. It's hard to concentrate.
I totally agree. And working as a consultant, being able to clock out and go for a walk is just so valuable.
Yeah, because it also benefits the company because your brain really doesn't stop processing the what you're doing, but you can really bill for taking a walk. At least I don't. Maybe I should. But when you're doing that, you're really thinking the problem that you're facing in the background.
Yes, very much yes.
Yes.
Going back to graphics, Chris, you had another couple questions.
There was one in the list here that I think we skipped over. That was kind of the crux of the difficulty of graphics on embedded systems, and that's if you're doing something moderately complicated, the dance between updating the frame buffer, syncing with updating the screen. I'd just like to talk about that a little bit to give people a sense for, okay, if you really want to do something that maybe has animation that's fluid and doesn't have tearing artifacts, how you go about architecting your system.
First, you have to describe what tearing means.
Oh, tearing would be, so if you're updating your frame buffer out of sync with how the display is perhaps reading it out, you might have half of your screen updated in the frame buffer and half old data, and then the display might read it out and put it on the display, and then you'd have this half updated screen, which since oftentimes you're moving something, it would look like you've got a big tear mark, a line across the screen.
So how do you solve that, right? It's I don't know if we can reveal this, Chris, but it's an ancient secret passed from generation to generation of firmware engineers, and it's called double buffering.
Yes.
Sorry, I gave it out. I'm sorry. I'm going to return my firmware engineer badge. So what you do typically is you have, instead of only one frame buffer, if you can afford it, you have two frame buffers of the display resolution. And while you're building your frame with the CPU or the GPU on one, you are displaying the another one on the screen. And to switch between the frame buffers, what you do is you wait for a signal from the display, which is most likely the vsync signal, which indicates that the display has started scanning the frame buffer. So once it started scanning the frame buffer, it will read from the active frame buffer all the pixels, and the pixels that it has read, they will no longer be used. So that's the moment where when you can switch frame buffers, and the active one becomes the backend, the back buffer, and you can start drawing your new frame there while the display that's in sync with the front buffer.
And so this is a ping pong buffer system where when ping is activated, is in use by the LCD, you write to the pong buffer, and then you wait for the signal to say to swap. And then the pong buffer is being used by the LCD, and you write to the ping buffer.
Yeah.
Yes.
And if you've got a display with an embedded frame buffer, usually they only have enough on there for one frame, right? They don't have double buffering. So you might have to add at least another buffer in your RAM. Well, how does that work?
Sometimes you can use you can't always read out the LCD's frame buffer.
Yeah.
That's usually kind of exciting too. And so you have to keep a shadow of what they have.
Right.
It's usually very slow to read the frame buffer in the display itself. So when the vsync comes, you send the active frame buffer in a one-way mode, and then start working with the information that you had on that frame buffer. Then there are tricks if your performance is not enough, or you don't have enough memory space for 2 frame buffers. You do like partial updates of the frame buffer. So you try to minimize the amount of pixels that you change, and then maybe you can get it fast enough to draw at the frame rate that you want to draw at. Maybe not 60 hertz, but maybe 30, and without seeing the disturbances on the screen.
Do you have any test methodologies? When I had to do LCD graphic system, I found later that I wished I had better unit tests to start with, involving lines and squares. And do you have a good way to figure out if you have written your graphic system correctly?
It's very hard to test. I wish I had a solution for that. Usually graphics have some form of user input involvement. So yeah, there are painfully involved ways of testing things, but I couldn't volunteer a solution for that.
Yeah, usually you accumulate a series of visual tests that you can run through, and
they're basically recordings of all of the errors that you have had to deal with.
Well,
because
in some extent,
test...
I mean, you start out with, this is what I think, this tests this functionality and it looks good, but you forget some corner case, or
usually it's an actual corner.
Exactly. And so you add that,
one.
you update the test, and so you end up with a suite of things that you can do. But like Gabriel said, it's very hard to automate that because it's a visual thing. So, I mean, you can kind of take screenshots and compare them against known good results, but that's all very painful. Yeah, it's a tough problem.
I remember writing the word red and green and blue in each color, and then realizing I hadn't written them in the correct colors because I wasn't sure which was R and G and B on my display.
That's a classic problem, mixing up the components orders. Yeah.
Yeah, when you have black and white, which a lot of times you start out with black and white, it doesn't matter. But then when you start doing animations for your team, suddenly it's important that red is red and not green.
Well, here's a question for you that the folks on the Slack might have asked, but they didn't. There's a lot of different display technologies out right now, and if you're building a hobby project or starting some small product, it might not be clear what the best thing to choose is. There's OLED, there's LCD, there's other things.
Matrix lights.
LEDs
are actually pretty popular right now.
And there's drawbacks to all of these, right?
Do I need to list the drawbacks?
Yeah, go for it.
Tell us first the drawbacks of OLED, because that may be important to me soon.
Oh, that's a pet peeve of mine. So OLEDs die in time. They're like little gnomes that emit light, and they get older and older each time you make them emit photons. And the more you make them emit photons, the more they die, the more quickly they die. So, yeah, that's a fun fact that I wasn't aware of when I started working with OLED displays.
And people like to choose them because they're super bright, and even the monochrome ones look really, really engaging.
But
really, we're just killing little gnomes inside.
Murdering thousands of gnomes.
Yes, that's scientifically been proven to be. Yeah, look them up in a microscope. Just enable kamikaze mode, and you'll see them in their little airplanes. Very bright.
But the nice thing about OLED is you don't draw power. Your power draw is proportional to how many pixels you're actually lighting, right?
Yeah. So each pixel is like an individual light, instead of being the LCD system where you have a backlight and you're basically filtering the backlight to produce colors. So the contrast appearance is much nicer because the black is really black. There's no light coming where the black pixels are.
And then color. I've heard the gnomes die at different rates.
Yeah. Blue dies especially fast. Not sure why. They're probably much larger because we perceive blue with a lower intensity. So to produce the same perceived blue and green, for example, brightness, the blue one needs to make a much more effort.
My story is that we haven't had blue LEDs for that long, so we're just not really good at making them.
Yeah, that's probably true as well. Or maybe the other pixels don't like blue.
Yeah, those gnomes hate the other gnomes.
Yeah. And they give you these curves, and they say if you're at 1,000 nits, this display can live for 100 hours, and then what you get is a pixel that isn't able to emit at its fullest, and depending on what you're showing on screen, you can get a burning effect, which is an image that seems to be constantly there, and that's produced by the lack of the pixels to emit light at the same level than the neighboring pixels can.
Well, that sounds fine. Not really, not at all fine. Okay, so OLED is
so if you manage to get all the gnomes to die at the same rate, then it's fine because you won't notice it for a very long time. The problem is when they start dying at different rates, forming a pattern, then you really notice that.
Okay, so LEDs might be an option, but those are very power inefficient. So I guess LCDs, those are fine. They've been around for a long time. They must work, right?
Yeah, they do. The problem is if you want to make a really nice looking device with no borders around it, it's very hard to do with LCD because they require a bonding area somewhere. So you get that if you look at wearable devices with LCDs, you see that somewhere they maybe advertise they run or whatever on a region because they cannot avoid having that section there.
And it has the backlight issue. You have to. There's very few LCDs that you can see. They have transreflective ones, which light coming into it is reflected off a substrate on the back, and then you can see it in daylight. But usually you have to have some sort of light emitting thing on the back, and that's usually some white LEDs or some fluorescent thing, which draws a lot of power.
So I should use e-ink.
You should use beeps. Morse code.
I do feel like we're going to get down to you just shouldn't have a display at all. Well, it's really better not to have graphics.
If you can avoid it, it's a big part of the power budget.
If you want a display, just watch the TV.
Yeah.
All right. Do we have more graphics questions?
That was the main one I wanted to go back to. I don't think we missed any in the list.
Well, I mean, the list is just there because
I know
I have to do something for the show other than talk.
Yeah, I have lots of questions for Gabriel, but he's not going to answer them.
I think I've already gone over the line with the double buffer and the Gnomes thing. I don't think I should have revealed that.
Okay, I have one more question for you then. When you were young, when you were the age that your sons are now,
yes.
What did you want to be when you grew up?
Yeah, I wanted to be an engineer.
Really? From that young?
Yeah. Yes. So, before I wanted to be an engineer, I actually wanted to be a garbage collection man, or so my mom says. But right after that, I wanted to be an engineer.
My stepdad was a garbage collection person. And in high school, I was like, oh God, don't tell anybody. Just say he drives trucks. And I found out a few years ago that I was the coolest person in the neighborhood to the 5-year-old who lived across the street when he found out that my stepdad drove garbage trucks. He was just like, that was the coolest thing.
Yeah, I was probably the same. Yeah.
But you knew what an engineer was, and you wanted to build things at a young age. Did you take things apart?
My uncle is an electronics engineer, so I guess that's where I picked that up from. Yeah, I was hated by my brothers. I constantly took apart toys and never put them back together.
Well, no, once you know how they work, who cares?
Yeah, my mom says that I went to the university so I could learn how to put the toys back together. That's actually true, yeah.
Well, I think we've kept you for long enough. Gabriel, do you have any thoughts you'd like to leave us with?
Yes, I'd like to read you a quote, one of my favorite. It says, it's from Douglas Adams from Mostly Harmless, and it says, a common mistake that people make when trying to design something completely foolproof is to underestimate the ingenuity of complete fools.
Yes.
A lesson to live by.
Yeah. Our guest has been Gabriel Jacobo, software, electronics, and systems engineer at large. You can contact him via Twitter, via his webpage, which will, of course, be in the show notes, or you can email us and we will forward it along. Thank you so much for being with us, Gabriel.
Thank you. It's been very nice being here.
Thank you to Christopher for producing and co-hosting. And of course, thank you for listening. You can always contact us at show@embedded.fm or hit the contact link on the embedded.fm website, where you can also find the blog. And now a quote to leave you with from Jorge Luis Borges. Plant your own gardens and decorate your own soul instead of waiting for someone to bring you flowers. Embedded is an independently produced radio show that focuses on the many aspects of engineering. It is a production of Logical Elegance, an embedded software consulting company in California. If there are advertisements in the show, we did not put them there and do not receive money from them. At this time, our sponsors are Logical Elegance and listeners like you.